All right, chemistry, this is your video lecture for chapter 2, section 2. We're talking about units of measurement. As we go through, there are going to be a few things I want you to learn. The first thing, I want you to be able to distinguish between a quantity, a unit, and a measurement standard. Those are going to be fairly abstract ideas for you, but you're going to need to hunker in and run them through your head. Identify the difference. Distinguish. That's the verb there. Name SI units for length, mass, time, volume, and density. Just a heads up, density is going to be a combination of the units of two of those other things we just mentioned. Distinguish between mass and weight. Those two things are different. Be able to distinguish between them. Also, be able to perform density calculations. We'll go over what that means later. And transform a statement of equality into a conversion factor. And I promise you that will stay with us the entire year. All right, starting out with the measurements. You make a measurement every time you, for example, measure your height, read your watch, take your temperature, weigh a cantaloupe or whatever fruit you like. When we're talking about measurements in chemistry, we measure quantities, how much of something we have, do experiments, calculate results, use numbers to report measurements, compare results to standards to see how we compared to the accepted values. When we do a measurement, we use a measuring tool. So a measuring tool is used to compare some dimension, we don't know which one, it can be any dimension, of an object to a standard, some standard one thing we compare it to. For example, if we are measuring body fat content, what we do is we measure the thickness of a particular skin fold around your waist, and we use calipers, and we measure the thickness, typically in something like centimeters. All right, centimeters is the 1 centimeter is the standard. Okay, thickness or length is the dimension. In every measurement, a number is followed by a unit. Okay, always a number and always a unit for every single measurement. So observe the following examples of measurements. A number in unit, okay, these are two columns. We have 35 meters, okay, 0.25 liters, okay, that's volume, that's liters, like a liter of cola. 225 pounds, okay, that's going to be weight. 3.4 hours, that will be time. If you see a number and a unit together, this is known as a quantity, all right? Remember that from your objectives. The metric system, also known as the SI system or international system, it's actually stated in French, so it's Système International, so that's why the S is first and then the I. But in English, we say the international system. This system, or both of these systems, I should say, are decimal systems based on the number 10. These are the most commonly used things in the world in terms of systems of measurement. They are used everywhere by scientists. Okay, here in the United States of America, we don't necessarily use these all that often, but when you enter into a laboratory or a science setting, you will see these systems used even in the United States of America. All right, in the metric and SI systems, 1 unit is used for each type of measurement. For example, if I'm going to measure length in the metric system, I'll always use meters, right? I might use some derivation of meters. For example, if something's very, very short, I might not measure it in meters. I might measure it in centimeters, but notice that meter is still there. The metric system unit for volume is liter. Okay, like a liter of cola. We already say you guys are familiar with 2-liter bottles. The metric system unit for mass is gram. Again, you can add prefixes onto that to change the scale there, like kilogram is something you've probably heard of before. The metric system unit for time is seconds. Like I mentioned in class, the age of the universe is actually measured in seconds. And then the metric system unit for temperature is degrees Celsius. Now, the international system, very, very similar, not exactly the same. We see the units for length are the same, the units for time are the same. But then we see that the unit for volume is cubic meters. All right, that's pretty abstract. The unit for mass isn't all that tough. It's kilograms. But the unit for temperature is Kelvin. Not degrees Kelvin, but Kelvin. All right, we'll talk about that more in the future. So when we're talking about length measurements, this is one of the things you're going to need to be able to do. Length is measured using a meter stick. Okay, uses of this unit. This unit is used in both metric and SI systems. All right, so anytime you're using one of these sticks, you're measuring length. When we talk about inches and centimeters, we can convert between the two things if we want, and you will end up wanting to do this throughout this class. What we do is we need a statement of equality, which, remember, the objectives will turn that into a conversion factor later, but realize that the unit of an inch is equal to exactly 2.54 centimeters in that metric system. So if I give you a measurement in feet, you can convert those feet into inches and then convert the inches into centimeters, and on and on and on. Let's talk about volume. Volume is the space occupied by a substance. It has nothing to do with its mass or how heavy it is. It's basically how much space it takes up. Volume uses the unit liter in the metric system. Okay, something that we use in the United States very commonly is the quart. 1 liter is very close to a quart. It's not exactly the same. A quart is just a little bit less. You need a little bit more than 1 full quart to be a 1 liter. In the SI system, they use the cubic meter. Okay, what you might use in this class to measure volume is the graduated cylinder. The picture over there on the right. To measure mass. Mass is the quantity of material it contains. How much stuff, how much matter is there? Okay, it's measured using a balance. Okay, not a scale. A scale measures weight. The metric system uses the gram, whereas the SI system uses the kilogram. So just a larger version of that same thing. They're both grams, one simply kilogram. All right, so I mentioned weight earlier and how it's different from mass. Let's look at that a little bit more closely. Okay, we have scales and we have balances. This thing on top is a scale. This thing on bottom is a balance. They're two different things. One measures weight, one measures mass. All right. Remember, mass is a quantity of matter. Okay, when we're looking at matter, we look at things like how much space it takes up. We measure it with a balance. Okay, the unit is often a kilogram, whereas weight, we're actually measuring the force of gravity as it pulls on that matter. Right? Gravity operates on every single thing that has mass. So the more mass you have, the more gravity pulls on it. Right? So we see a correlation here on Earth, since gravity is essentially always the same strength. So as mass goes up, so does weight. But realize, if you're on a different planet with a different force of gravity, your mass will still be the same, even though your weight will be different, because it's how strongly is gravity pulling on that matter. We measure weight with a spring scale. A common unit that you probably won't use in this class all that much, but you would use in physics class is called a Newton. All right, so think to yourself, on the moon, will our weight or mass stay the same? Which one stays the same on the moon? It is our mass. All right, the moon has a less force of gravity, or smaller force of gravity. Talking about temperature, one of the other things we need to be familiar with, and its units in this class. When we're talking about temperature, it indicates the amount of kinetic energy present in that substance. Okay, kinetic energy is something that we'll touch very lightly here in this chapter, but we'll leave it for the thermochemistry chapter later on. For the metric system, we use the Celsius scale. Degrees Celsius is the unit. On this thermometer that we're being shown right here, we can measure that as 18 degrees Celsius. All right, but if we're going to use the SI system, we would say Kelvin. We wouldn't say degrees, we would say Kelvin. Okay. If we're talking about time, the measurement of time, we use seconds in both systems, metric and SI. And it's actually based on an atomic clock that uses a frequency emitted by pulses emitted from a cesium atom, or a group of cesium atoms, because it's particularly consistent. This is a table of different quantities, their unit, and then the symbols that you would use to record those. Okay, use this for your reference. We're going to talk about density, and one of the things we need to talk about density is volume. So again, here's a list of the different units of volume that we will be using throughout this class. And over on the right, we have statements of equality. please remember the statements of equality. You'll be using those to make conversion factors later. Let's talk about density. Density is the amount of mass per unit volume of a substance. Okay, so we're taking into account both mass and volume. The examples we have down here, we have steel. We have 1 cubic meter of 3 different things. We have a cubic meter of steel, cubic meter of wood, and a cubic meter of air. The unit of volume is always the same. However, you can imagine that a cubic meter of steel is going to have much more mass than a cubic meter of wood, and a cubic meter of wood will have much more mass than a cubic meter of air. And so what we see is, since the denominator will always be the same, right, 1 cubic meter, but the mass, the numerator, for steel is large, for wood is medium, and for air is low, you'll see that that fraction, as you become less and less dense, that fraction becomes smaller and smaller. Some common units that we'll use in this class are going to be the grams per cubic centimeter or grams per milliliter. All right, and we'll show you some examples here. So calculate density. Remember, one of the objectives is to calculate density. Let's say that lead has a mass of 22.8 grams and its volume is 2.00 cubic centimeters. What is its density? So we have 2 pieces of information here, and they're the 2 pieces of information that we need. Mass, 22.8 grams, volume, 2.00 cubic centimeters. Density equals the amount of mass per unit volume, so it's mass divided by volume. So I'll take the 22.8 grams and then divide it by the 2.00 cubic centimeters. I simply plug the 22.8 divided by 2 into my calculator, and I get 11.4. Now notice, I can't do anything with the units. The units stay there. So my unit for density is grams per cubic centimeter, like we said is a very common unit in previous slide. All right, these are some internationally agreed upon metric units. Okay, again, this is here for your reference to use as you go through different calculations. Again, another table for your use. These are the prefixes that you'll have to be aware of for this class. Mega, kilo, hecta, deca, dessa, centi, milli, micro, nano, pico, and femto. Femto, not so much. Pico, maybe a little bit, but mostly nano and micro are the smallest things you're going to need to be aware of. Again, use this for your reference. When you're practicing your problems, have your notes open and using. All right, let's see how we're doing. For each of the following, A, B, C, and D, indicate whether the unit describes length, mass, or volume. Which one? Okay. I'm going to please press pause on the video and come up with your answers for each, and then press play once you've generated practice answers for each. All right, let's see how we did. A is mass. A bag of potatoes is kilograms. You see kilograms. A person is 2 meters tall. That is length. Okay, number 1, that's length. 0.5 grams of aspirin, that's going to be mass. A bottle that contains 1.5 liters, that is volume. All right, I hope you got these correct. Another one, go ahead and press pause, come up with potential answers for each of these, and then press play when you're done. All right, let's see how we did. John's height is in meters, right? It's a height, it's a length. The race was won in seconds. That's a unit of time. All right, C, the mass of the limit is in kilograms. All right, in the kilograms, we're talking about SI units here. SI units, we have ounces, we have pounds. Those can both be used as mass, but the question says SI units, so we use the kilogram. The temperature is Kelvin, because we specifically asked about the SI units, so it's 255 Kelvin. Talking about conversion factors. This is one of your objectives. A conversion factor is a ratio, okay, 2 numbers compared to one another, a ratio derived from the equality between 2 different units that can be used to convert from one unit to another, because we will be needing to convert from one unit to another. So a conversion factor is going to look something like these examples I have here. 4 quarters equals $1. $1 equals 4 quarters. $0.5 equals 1 quarter. All right, you guys know this from experience. You're very familiar with this. But one thing I want to point out is that when you divide these out, they all equal 1 because they're the same thing. The numerator is the exact same thing as the denominator. They all equal 1 when you actually divide them out. Keep that in mind. So here's an example of how to use a conversion factor. I want to convert 5 kilometers to meters, all right? So I set up my conversion factor. I start with the 5 kilometers, and I multiply by something that is equal to 1. Notice that in every 1 kilometer, there's 1,000 meters, because that's what kilo means. Please refer to the table earlier in your notes, right? 1 kilo equals 1,000, all right? Now, you'll notice the unit that I'm moving from on my conversion factor, I put on the denominator. The unit I want to move into, I put on the numerator. Here it's red, okay? The red thing is my new unit. The green one is my old unit. Because I'm dividing something by itself, kilometers by kilometers, I get to cancel them out. That's why I have lines drawn through them. And the only unit I'm left with after I do all my calculations is meters. And that's exactly what I want to happen. I want to have my answer in meters. All right? And I simply plug that in the calculator. I have 5,000 meters, right? 5 kilometers is equal to 5,000 meters. That's what we've accomplished. Okay? What I'd like you to do right now is go ahead and press pause and see if you can convert 7,000 meters to kilometers. Again, use the process I just described. Don't do this in your head. Do this on a piece of paper. Press pause now. All right, let's see how we did. So we have 7,000 meters. That's what we're starting with. We're going to set up a conversion factor. We have to multiply when we do conversions. All right. And I'm going to set up my conversion factor with kilometers on top, meters on bottom. Meters on bottom because I know I need to be dividing meters by meters. Okay. Because I've gone meters divided by meters, I can cancel them out. And the only unit I'm left with is the thing on top on the numerator. That's kilometers. So my answer will be in kilometers. Now I only have to deal with the numbers left in the question, so I plug that into my calculator, and I come up with 7. 7,000 times 1 divided by 1,000 is 7. So let's see, hopefully, what we've accomplished so far. I want you to distinguish between a quantity, a unit, and a measurement standard. We did that early in the slideshow. Name SI units for length, mass, time, volume, and density. Okay, there are several tables throughout your notes to help you with that and reference. Distinguish between mass and weight. Okay, this is more of an idea, but you need to be able to distinguish between the two. Perform density calculations. We even included some sample problems for that. And then transform a statement of equality into a conversion factor. We did that here at the end. And again, we included some sample problems. So please refer to these sample problems regularly. All right, I will see you next period.